Our applications are often required to make calculations that involve the values of specific attributes, constants, and/or functions. For all these cases, GeneXus offers formulas. There are two possible ways to define formulas. With a global definition, the calculation will be known throughout the knowledge base. Or, with a local or inline definition, the calculation will be known only in the object where it has been defined. Let's start by learning what a global formula is and how we can define it. A global formula is a calculation we define in association with an attribute. Note that the transaction structures contain a column labeled Formula. When a calculation is defined in this column for an attribute, we will tell GeneXus that the attribute is virtual, meaning that it must not be created physically as a field in the associated table because the value of the attribute will be obtained by doing the calculation we mentioned. Let's see this in an example. First, we will define a new attribute in the flight transaction in order to record the price of each flight. So, we define the flight price attribute and create the price domain. Then we save. Now we will define another new attribute in the same transaction in order to record the discount of each flight. We will call it flight discount percentage. And its data type will be a domain also called percentage, which we will define now. It will be numeric and 3 in length. Lastly, we will define yet another attribute called flight final price. Based on the price domain, with the purpose of defining it now as a global formula. To do this, in the new formula column of this attribute, we define the calculation required for it to be executed every time and to have available in this attribute the actual flight price. That is, the price that results from deducting the discount percentage recorded in flight discount percentage from flight price. So, in this formula column, we will write the corresponding calculation. Now we press F5 to automatically save everything that is pending. And let's see what happens. We can see that only 2 fields are created in the flight physical table, even when we define 3 new attributes in the transaction structure. Given the fact of its definition in the formula column, this attribute is not added to the physical table. Since the attribute is defined in the knowledge base with an associated formula, GeneXus knows how to calculate its value. And in all objects with that attribute, the calculation will be done and the results shown. Then we reorganize. And now here we have the application at runtime. We execute the flight transaction and query flight number 1. In this form, we can see the 3 new attributes we defined. The flight price, enabled for us to enter it, the discount percentage, also enabled for us to enter it, and the final price, disabled because it is the attribute we defined as formula, and we do not enter its value. It is calculated and deployed. All the attributes we may define as global formulas will be read-only data without the possibility to type in a value for it. This is because the attribute obtains its value from the associated calculation, which is executed every time that the attribute is used. Also, there is no field in the physical table to store the value of this attribute, so making it editable would make no sense either. We will then enter a price for this flight, then a discount percentage. Let's enter 10%. And now we exit the field and see that the formula is executed immediately, showing the flight's final price after applying the discount. Let's now get back to GeneXus. So far, we've defined a global formula attribute. Only attributes may be defined as global formulas in the way we just saw, using the formula column in the transaction. It is important to bear in mind that, even though in the calculation of the example, we only involved attributes of the transaction itself, it is possible to also involve attributes from the extended table. Let's see this. Let's create a new transaction called airline to record the different airlines. So we define airline ID, airline name, and airline discount percentage to record the discount that the airline applies to all its flights. We save and go to the flight transaction to assign the airline corresponding to every flight. We then add the airline ID attribute, which here will have the foreign key role, and we change the value of its nullable property to yes, so that we have the ability to not specify the flight's airline in this first stage because we still have no recorded airlines. Further ahead, we can change the value of this nullable property to no so that specifying the airline becomes mandatory at the time of entering or modifying a flight. We also add the airline name and airline discount percentage attributes in order to also view this data on the form. We now modify the definition of our formula for it to calculate the flight's final price by applying the airline's generic discount instead of applying the discount corresponding to each flight. We then press F5. We see the proposal for the creation of the airline physical table with the three attributes we defined, so that in the flight table, the airline foreign key will be added. We then reorganize and execute. We execute the airline transaction and enter an airline called TAM with a 30% discount. We now assign this airline to a flight. To do this, we open the flight transactions, our flight number 1, and associate it to airline number 1. We can see that the flight's new final price has been calculated, and that it's a global formula attribute because it now involves the airline's discount percentage, which is an attribute in the extended table of the flight base table. So, something we still have to mention is that formulas may assess conditions, and the result may be calculated in different ways depending on whether such conditions are true or false. Let's see this. Let's click on this button to edit the formula. And we will also define that the highest discount percentage be considered in calculating the flight's final price so that the discount is the best possible. With this definition, if the airline has, for all its flights, a discount higher than the discount percentage of the flight itself, then we consider the airline discount for the calculation. Otherwise, we apply the flight's own discount percentage. We then press F5. When we execute the flight transaction and the first flight, we assign it so that its discount percentage is greater than the airline's overall discount percentage. For example, here we will assign 50%. We can see that the flight's final price was then calculated with the greater discount. Now let's get back to GeneXus. As we just saw, formulas may contain several if lines one after another, and may contain a last line with otherwise or not, for the case where none of the above conditions have been complied with. Also, even when this example shows the way to obtain each result through a calculation, it is also possible to resort to functions applied to attributes or calculations, such as round, to obtain a rounded figure, or month, to extract the month from a date, and so on. And we can even call a procedure we defined ourselves to return a value. So, now let's move on to another type of formulas called aggregate formulas. In addition to explaining these by defining examples of global formulas, that is, defining the corresponding calculations in association with attributes, so they will not be created as physical fields, our explanation will also apply to a different context, such as a variable, for example, or locally in a specific section of an object. We will be seeing this in another video. So now, let's create a second level in the flight transaction and call it seat. As this level name indicates, we will use it to record the seats offered on the flight, and we will record for each seat, whether it's a window, aisle, or middle seat. We will then want to always know the number of seats available on the flight. We type in the dot and fill out the name of the attribute, Flight Seat ID. Now we create another attribute with the name Flight Seat Location, which will be a character of 1 digit. Now we go to the Domains node to change a property in the location domain we've just created. We find the enumValues property and define the 3 values possible for this domain. Window, in which case the character stored will be W, middle, in which case the value stored will be an M, aisle, where the value stored will be A. So we press OK. And we can see the form of the flight transaction. We can see that a grid was added to enter the flight seats, and for each seat, we can indicate its location through a combo control. This combo provides values window, middle, or aisle, all of which are possible values we define for the domain of the flight seat location attribute. Before pressing F5, let's see something in the second level definition. If the key comprises flight ID plus flight seat ID, we will not be able to repeat flight seats for each flight. But we must be able to consider the possibility of having repeated seat numbers with a different character next to the number, since it's common for seats to be identified as 1A, 1B, and so on. So we will add a new flight seat char attribute. And define its type of a seat char domain. Which will be a character of 1. And we will cause this attribute to be part of the key so that we can record the same seat number with a different letter. We will limit the possible letters used to be from A to F. To do this, we edit the seat char domain we've just created. We find its enum values properties and define the possible values. In this case, the values of descriptions match the values stored. We then press OK. And now to know the flight's allowed passenger capacity, we will define a new attribute in the first level indicating, in its formula column, the calculation to count the number of seats available on the flight. We then create the flight capacity attribute and its data type, which will be numeric of 4 digits. Now, in its formula column, we write count and a secondary attribute of the second level between parentheses, such as flight seat location. And we close parentheses. The attribute referenced inside the parentheses of the formula provides GeneXus with the information of the table to be navigated to do the calculation. Then, if GeneXus detects a relation between the table it will navigate and the table where the formula attribute is defined, it will only consider the related records for the calculation. In this example, we can see that flight ID is present both in the table where the formula is defined and in the table to be navigated for doing the calculation of the formula. So, only seats of the flight where we are now, and not all seats recorded in the navigated table, will be considered. If no relation is found, then GeneXus will do the calculation considering all records in the navigated table. Let's try this at runtime. We press F5. We can see that the physical table flight seat will be created in association with the second level of the flight transaction, with the attributes and the key we have defined. And the structure of the flight table will not be modified because the flight capacity attribute will not be created physically as we expected. Since we agree on this, we now go on to reorganize. We execute the flight transaction. We query our flight number 1, and we go on to assigning some seats to it. 1A, window. 1B, middle. 1C, aisle. 1D, window. 1E, middle. 1F, aisle. As we add the seats, we note that the seat numbers are updated every time we add a seat to the flight. Let's now add one more. 2A, window, and we'll leave it here. Now we go back to GeneXus. We also have the aggregate formulas, which do calculations upon considering several records, such as, for example, sum, average, and others. It is also possible to count, add, or average specific records that meet a certain explicit condition indicated by us. For example, if we want to count the number of seats by the window on the flight, we add to this formula, inside the parentheses, a comma, and the corresponding condition. Since the flight seat location attribute is of the location domain, and it has 3 enumerated values defined, then the syntax to request the value that the attribute has taken is as follows. Name of the domain, dot, and the name associated to the value that we want to filter, in this case, window. We press OK, and F5. We execute the flight transaction, the record number 1, and see that the capacity now shows a quantity of 3, which corresponds to the number of seats located next to a window, and this matches the entries we made in the seat grid. And lastly, we must know that, as any global formula, aggregate formulas may also include a triggering condition. This means that it's possible to add an if at the end of their definition, with a specific evaluation so that the formula is triggered only when such condition is true. And to close, we send the new definitions to GX Server.